So now, what are the two meanings for day? What does it mean to have a day? You kind of know, but there's 2 points of view, right? There's what we see from Earth and what people saw for thousands of years, which looks like sun rises, goes higher, sets, and goes around us each day. That's what it looks like. And maybe you know that that's not the case, but you can forgive our ancestors for thinking that because it sure looks like that, right? So what does it mean to have a day? I mean, you could say, start whenever you like. I like noon, you'll see why. But a day as seen from Earth is 12 noon. People get confused AM, PM, but 12 noon. Then we have it sun on the meridian, past the meridian. Sun sets as we cross the terminator, we'll see that, into the dark. Still PM, so PM when there's light out, right? Also PM, 12 midnight, then it crosses. AM, sunrise, about 6 a.m. That's good enough for us right now. Sometimes we'll just have an approximation. We'll go 12, 6 p.m., 12 midnight, 6 a.m., before the meridian, antes, before, ante, meridian, and back to noon. How long does that take? Well, 24 hours. That's how we set our clocks. That's how we do it. Noon to noon, called a solar day because we're looking at where sun is. Sun high overhead, sun high overhead. A solar day, 24 hours. And in the text, that's picture 1 to 4. I've covered that because we need to do some work. So to understand what's really going on and how we connect what's really going on, actually going on as seen from space, with what we see, you need to get a sense. Here's a softball. So if I take a softball and have that represent sun, so imagine sun and shrink that star down to the size of a softball, right? So you've done that, and you think about shrinking Earth. How big would it be? Would it be half as large? It would be about a grain of sand. You see, you can get about 100 Earths across sun. Sun's width or diameter is about 100 times wider than Earth's width. Closer to 109, but 100's good to remember. So you can remember 109 if you want, but it's a grain of sand. Now, where would it be? How far away would that grain of sand, Earth, orbit sun? And the answer is about 10 long steps, depending on how tall you are. 10 long steps in this planetarium. That would mean, put sun here, that grain of sand would be at that back wall. Ten long steps. Okay. So we're going to use that idea, and I'll come back to that. But just remember, when I do my drawings, I can't draw it to scale. I can't show the sizes and the distances. So my pictures will have exaggerations, but you'll get the point. But you have to make sure that you're thinking of it correctly, right? So now if I throw this to someone at the back of the room, they hold it there, and I've got the grain of sand right here. I put it right on my pinky tip. We're going to talk about this in a bit too, but I might as well go there. Moon, if I take same size grain of sand, cut it in half, take one half, cut it in half, it's about the size of moon, and it would be orbiting right here around Earth at my pinky tip. Sun being softball at that back wall, 10 long steps away. Okay? Earth and moon going around sun. Okay, so we'll be working on that. Now it becomes a little bit important to add that information. So what does, check our point of view. All right. So what's a day? Let's explore this. This one's a little tricky and very important for understanding seasons, moon phases, tides. So here we are. We know that Earth spins eastward. Remember that. I'm going to take the point of view of my head being Earth, my eyes being an Earth observer. And so we're going to have a, what's that view? Top view, North Pole, South Pole, spinning eastward like this. So instead of Earth spinning, I'm going to spin my head. There's a light right there. And perhaps I should make it more dramatic lighting, but we're going to imagine Earth observer. Goes, hey, let's head this way. Look at sun. Sun is high over my sky. There's a light bulb right there. There's sun. Let's do it this way. Earth is spinning eastward. Notice that I'll see you. Right now I don't see you. I come around and I start to see you rise up higher and higher in my sky. Oh, rising in the east and heading westward, setting in the west. So you're going west as I spin east. It looks like you're going west, but in fact, I'm spinning east. Okay, got that? Just try that yourself. People think you're crazy, that's okay. Better that. So here it is, rising in the east, setting in the west. Everything seeming to go westward, when in fact it's me that's spinning eastward. And so too, if it's sun, good enough. If it's sun, got my E backwards enough. If it's sun, then I get, oh, sunrise. Now, it's nighttime, oh, sun is rising. Now look at where she points. Sun is rising. Sun is getting higher and higher. Antes meridian, before the meridian. On the meridian at noon. Sun is getting lower. And look, still back wall. So there's my light bulb. Let's just call the back wall sun. Getting higher and higher. On the meridian around at noon. Say past the meridian, p.m., sunset. Let's call that 6 p.m. Nighttime, 9 p.m., 12 midnight, 3 a.m., 6 a.m. sunrise, 9 a.m., 9 a.m., 12 noon, 3 p.m., 6 p.m. sets. That's my experience of a day. But I'm connecting 2 points of view. In reality, I just see sunrise. And we know that with the seasons, sun does rise and set at different places on the eastern horizon, rises, and sets at different places on the western horizon, and it's out different lengths of time. We'll get into that, and so it'll rise and set at different times. So it's a little complicated, but we know basically we're going to go from noon to noon. And that means sun is over my head, right? It's not going to be on my eastern, this is my ground, this is my horizon, right? She's amazing because she gets that's her horizon, and up high in the sky is sun. So when it's over her head, or at least highest during the day, we got that as noontime. Okay, so let's work this a little more. Let's draw a picture. So now I'm going to come over here, give you a little ride in your spaceship, and we are going to, here we go, take a look at the book. Your Astronomy Coach by me, Celestia, whatever. And let's see what the book's telling us. Okay, so notice, this is North Pole. Now I'm drawing it as a top view. I just did a side view. Now I'm going to do it as a top view. A little easier to see. And we'll leave our sheet behind. This is important as we get into the next couple of sections. I've drawn an arrow to show this is her ground, right? Make that green. Draw her. You can put legs and arms if you want. You can put hair if you want. And she is going to spin around as she just stands still, but Earth will spin eastward. So draw that arrow. Notice that east, there is no east in space. She's got to tell you which way. San Francisco, Washington, D.C., San Francisco goes to DC every day. That's east, that's east, that's east. As it spins, San Francisco follows Washington, DC, round and round. One spin being a day, but there's some subtlety here. Okay, now for her, can you see that she's looking over her head, or at least high up in the sky and southward towards sun? Now this picture's crazy, first of all. If she's that tall, then she should be in the NBA. But the distance to sun is crazy too. Because if Earth was a grain of sand before, and sun was at the back wall, now Earth is much bigger. Sun would be very, very far away. So we're going to adjust for that. Keep that in mind. But we see that if she were to see sunrise, it would be there, over east, and set here. When does she see that? Oh, let's check that out. You've got that sense of this being a globe. Okay. She's standing on Earth. Don't worry about latitude. She's standing on Earth. And here she is. Okay. Good enough. And she would see sun that way. Don't point at the sun that I've drawn, because sun is way out to the right. To the right. Not to my picture, but to the right. Always to the right. So she sees sun to the right. Oh, rising over, getting higher over her east horizon. Over her head at noon. Can I do it? Let's see if I can hold on to it. Now past the meridian. Lower and lower on her west horizon until she sees it setting in the west. In fact, sunlight would hit which side of this globe? Right side. Here would be our terminator, and this would be night. Day and night. Sunrise across the terminator around 6 a.m. Good enough right now. Gets higher and higher. 6 a.m., 9 a.m., 12 noon, 3 p.m., 6 p.m., 9 p.m., 12 midnight, 3 a.m., like that. Draw this. Draw the terminator, shade the dark sky, day, night, day, night. If you can see that, now we're cooking. All right, so keep that in mind. Imagine her spinning around. Earth appears to move westward, rising in the east, moving west. In fact, what's happening is we are moving east very rapidly. Okay, so let's see. So if we're going noon to noon, we're going sun high over our heads, however high it is, depends on your latitude and time of year, but whatever. Not on our horizon, not on our east horizon, not on our west. Draw that arrow, you know that's east, you know that's west. This is our ground. Sun is between east and west, and the meridian divides the sky into an east and west half. So there it is, noontime. Spin around halfway, 12 noon becomes 12 midnight. But let's do a quarter void. 12 noon becomes 6 p.m., right? And she sees sun setting over her west. Do not draw this. This is a big thing. Don't draw it at my picture. Sun, in reality, way, way out there for my picture. And we'd be a teeny, right? So it'd be way out there. Don't draw it this way. I would say sun is there, not there. Keep? Okay. So over the west horizon, this was 12 noon, 6 p.m. Notice that if I drew the terminator, shaded the dark side, she'd cross the terminator, and we'd have sunset. Let's keep going. Crossing the terminator, 6 p.m., 12 midnight. Think of that as being dark. I want you to fill that in your head and on your paper, if you will. crossing the terminator, continuing to spin eastward, east, 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 around 6 a.m., good enough for now. To get the idea, she sees east, she sees sun rising over her east horizon, and back to noon. Okay, you've got it. I hope. And so if I go like this, what am I showing? I'm showing that it's going to be, what time? Noon. 12 midnight. 12 noon. Right? So that would be one spin. Now, this is the trick. This is noon to noon in my picture. If it spins once, then she's going to point to the right of the page, starting here and ending up pointing to the right of the page. Forget about sun. One spin, she's pointing to the right. However, while she does that, riding this beautiful blue marble in space, we orbit. And so we shift. And I don't know if you can imagine that, but we start here, noon, and she's going to spin once. But if we move it around here, then that direction, it's not quite noon yet. And I know it's a little bit funny, but go with me on this. So, taking a look here, totally exaggerated. It's a very small effect. I'm about to tell you why. I spin around once, I'm back there. So to spin around once, halfway, once, I'm here. This is noon. This is not noon. Sun is not overhead. I know I said think about sun way, way out there, but for now you get the point with this picture. It's not overhead. One Earth spin is not noon to noon. Noon takes a little longer. Now it's noon. Noon to noon, one Earth spin. Seen from space, seen from Earth. Let's take a look at that over here now and complete this topic. And of course, you can get away with not worrying about this. However, it trains a way of thinking. So let's do the big reveal. Seen from Earth, noon to noon, say, 24 hours. What's really happening is Earth is spinning once. It spins which direction? You know the answer to this, don't you? Eastward. On this picture, I have shaded drawn the terminator, shaded the dark side, top view with North Pole there, getting used to all this stuff. East, west horizon. She would see sun not on the horizon, but high up. Sun at 12 noon on the meridian. The line that goes from south to north, north to south, dividing the sky into east and west halves. We call this a sidereal. Sidereal means relative to the stars. Don't overthink that. Sometimes I flip that and say is dereal day. It's the time to take one spin on Earth. And that takes, remember the picture, more or less time. Don't guess. Visualize the picture. 23 hours, 56 minutes. About 4 minutes short, good enough. So it's very small. However, there are folks that keep track of this, and that's a good thing. So we've trained an awareness of what it's like to ride on a spinning and orbiting sphere in space. Not a perfect sphere, but nonetheless. Noon, sunset, midnight, sunrise. We're going to work on that. If you get that, you are golden. To move on to the next one. Okay.